I see you're back for more lesson 3 of digital learning week 1. Thanks so much for hanging in there. Some of you might have been watching these back to back. Others of you might have spaced them out. But either way, I'm glad you made it here. As of the last lesson, we talked about this idea of the circumference being a way to describe the distance around a circle. And we also talked about this idea of arc length representing a part of the distance around a circle. We're going to use those ideas with the idea of the area of a circle and sector in order to talk about the size of the space enclosed by a circle, as well as the size of the space enclosed by part of a circle, known as a sector. Now, some of you might be familiar with the area of a circle formula, which is, of course, pi r squared. This is a formula you've been introduced to in the past. And it's basically a formula that does the idea of taking a circle, and it's really, if you haven't seen this before, this exact value comes from a process of approximation of your calculator trying to find the biggest square that fits inside of a circle, and then it tries to fill the space around that it couldn't fill with the square with smaller squares. Oops, that's not a square. Smaller squares. Try again. You get the basic idea, though. It basically fills this space with a square. There we go. And then it says, uh-oh, there's still some space here. I can fill this with a square. And it does that so on and so forth until it comes in an approximation, which just so happens to be exactly pi times the radius squared, which is pretty cool. So how can area of a circle be helpful for us? Well, again, we're going to kind of jump into some word problems and some things to talk about it, but we can find areas in order to help us with some real-world problems that might deal with the situation you're in right now, such as when you order pizza because you don't want to cook anymore because you're going insane from COVID-19, what are you going to do? Well, are you going to buy 2 medium pizzas or 1 large pizza? What's the better deal? You'll find that most people make silly decisions when they try to order these because they don't realize how much larger the large pizza is. Let me show you an example. Again, let's say you say, well, 2 8-inch medium pizzas, that's huge. That is way bigger than 1 12-inch large pizza. Is it really, though? Because remember, we're not talking about the size of the diameter, which is what each of these are. That's the diameter of the pizza measured from one side to the other. We're talking about the actual area that is enclosed by that pizza. So what that means is, again, if we actually notice that our 8-inch medium pizzas only have a radius of 4, but our 12-inch pizza has a radius of 6, what we'll find is that the area of any medium pizza is really only 16 pi inches squared. If we have 2 of those pizzas, that's 32 pi inches squared. But our single 12-inch pizza is really 36 pi inches squared of area. Notice that that actually is more pizza than you're getting if you buy 2 mediums. And actually, it's even more pizza than that, because those of you who haven't thought about it, when you buy a pizza, you're not just buying all the stuff inside. You're buying a certain amount of crust and then all the stuff inside. Well, guess what? If you buy a medium pizza or a large pizza, the size of the crust isn't necessarily any larger. What that means is the relative size of the amount of stuff you get inside of all those goodies is actually even bigger than this discrepancy would show. All that to say, almost always getting the largest pizza size is better than getting multiple of the smaller sizes, which is pretty wild. It's close, but it's still a better deal. Now, to build a connection to yesterday, we can talk about the fact that if someone tells us the area of a circle, we can navigate from that in the formula we know to find any relevant information they might ask us. We can find how large the radius of that circle is. We can find the diameter. We can find how large the circumference is to go around the pizza, for example. Or we can also find an arc length. So if I trace my finger around 1/4 of the pizza crust, how far will I have traced my finger? All these are possible as long as we work with our formulas. Because if we see that the area of a circle is 144 pi, and we know that the equation for a circle is pi times the radius squared, we'll say, well, wait a minute, that pi came from that pi. And that means this 144 is the radius squared. Well, what's the square root of 144? Hey, it's 12. And if my radius is 12, my diameter is 24. And if my diameter is 24, I know to go to circumference, the factor of change is pi. So my circumference is 24 pi. And just like that, we have a connection with the area of a circle, the radius, the diameter, and the circumference. They're all linked together. And in fact, you can think about it as a pathway from area to radius, from radius to diameter, from diameter to circumference. They all connect in this nice chain link. And again, we can go the other way with it too. So if you look below, they tell us the circumference. They want to know the area. Well, we have to go from circumference to diameter first. Well, if the circumference is 28, and I want to go to the diameter, I'm going to something smaller. I need to divide by that factor of change, pi. So 28 over pi is my diameter. And then I want to go from my diameter to my radius. Well, to go from my diameter to my radius, I need to divide by 2. So the radius is 14 over pi. And then if I want to go from my radius to my area, I need to remember that the formula is radius squared times pi. So I'm going to have 14 over pi squared times pi. That is my area. Again, throw all that in a calculator, and now I can report not only the diameter of this circle and its radius, but also its area, when only given one measurement, the circumference. And again, it's because they're all intimately linked together. The radius linked to the area, the radius linked to the diameter, and the diameter linked to the circumference. It's pretty cool. Now notice we can start doing more complicated problems as well if we would like. One thing that we might do here is we might try to find the area between a circle and an isosceles triangle. Now what we're going to notice here is that we have an isosceles triangle, which means we have congruent legs, and that means the change, which is from 13 to negative 12, back 25, up 5, down 5. So this point is negative 12, negative 5. Well, let's say we want to find the area of this particular shaded region. What we're going to need to know first is we're going to need to know the area of the whole circle. Well, to find the area of the whole circle, we're going to need to know the distance from the center of the circle to any point on the edge. Well, you'll notice the easiest distance to find is this horizontal distance right out here. Because from 0, 0 to 13, 0, I do my distance formula, and guess what? The only change is the change in x, which is 13 units. That means my radius is 13. Thus, my diameter is 26. If I want to talk about finding the circumference, and I can also go a different direction, which is to say the area is the radius squared times pi. So this is my area of my large circle. Well, now I can compare that to the area of my triangle, which is the section I'm cookie cutting out. And again, you might remember that the area of a triangle is 1/2 base times height. Well, do I know the height and or the base of the triangle? Well, let's see. I know the base. The base is going to be 10 units in length, because from this point back here, I travel 5 units up and 5 units down. So I have a base of 10. But what I don't know is I don't know my height. Or do I? It's something that I can find quite nicely, because the center of this isosceles triangle is directly on the x-axis. The change in x from this base all the way to this point on the front is 25 units, which means the area of my triangle is 1/2 10 times 25, which is 125. So what's the area of the shaded area? Well, all that it is it's the area of my circle minus the area of my triangle. So it's 169 pi minus 125. And again, I can throw that in a calculator if I want an exact value. But you'll notice that now that we have all these tools to connect our radius, our diameter, our circumference, our area, we can now start doing more involved processes, thinking about how we could use the area of a circle or parts of it in order to find other areas within it. And again, this one's one cutting out a triangle, but we could really cut out any shape or combination of shapes, which is pretty cool. Okay, now I've alluded to this above, but one thing that we're going to talk about is basically a section of the area of a circle. And this is where you're going to start to see pieces similar to this where we cut out a part of the circle. But we're going to cut it out from the center, and we're going to cut it out like a pizza slice. And this is what's called a sector of a circle. A sector is the region bounded by two radii and the arc. In other words, it's a pizza slice. We pick two radii, a distance from the center to the edge, and everything in between. That's our sector. And just like when we talked about finding the length of an arc length, which was a proportion of the whole thing, that's the exact same thing for the area of a sector. The area of a sector, compares to the area of the circle, just like the angle of the sector compares to the angle of the circle. In other words, it is precisely the same process as finding arc length, because we're just finding a part of a whole. So watch how nice this is in practice. Again, we want to find the shaded area of our circle. Well, what do we know? We know the shaded area has an angle measure, this arc here, of whatever 360 minus the 80 that is not in the arc we care about is. Well, that's going to be 360 minus 80 is 280 degrees. So my arc of my circle is 280 out of the 360 that there is in total. That's the shaded arc. And I want to know the area of the sector. Well, I just need to compare that to the area of the whole circle. How do I find the area of the whole circle? Well, I find that radius, I square that value and multiply by pi. So I get 144 pi. Bam, bam, boom, multiply by 144 pi. And whatever that is, throw it in a calculator. That is the area of that shaded pizza slice. Done. Super easy. And again, we can use this idea of proportionality to find any of the relevant pieces we talk about. So if somebody gives us a section and they say, here's the area of the shaded region, cool. What angle would create that much area, right? What angle do I cut the pizza at so I get to eat exactly this amount of pizza? Well, guess what? The process is exactly the same. I say, well, look, it's 45 pi out of the total. Well, the total area is 18 squared pi, which is, oh gosh, it's some number. It's a number, kids. 324? I think it's 324 pi. Double check my math, but that is the area of the whole circle. So I say 45 pi out of the whole circle is angle of sector compared to 360. Well, again, if I want to get the thing that I want to know by itself, I need to multiply, in this case, both sides by 360. Throw that in a calculator, and the angle of the sector is whatever that final answer simplifies to be. So again, once we set up the proportion, the rest of the process is really easy to handle. So again, to summarize, what most of today is about is taking the idea of parts of circles and expanding from the idea of parts of circles in an arc, like we talked about in the last lesson, to parts of circles in terms of their area, slices of circles. And this allowed us to establish the idea of sectors and use this idea of proportion, the part we're looking at compared to the whole thing, both with respect to the angles and the areas, or the angles and the circumference sections in order to find even more unknown information. And that really is all we have for you today. So this is the first week. It's really just been 3 pieces and 3 tools to work with. It's been reminding us how to factor and break apart quadratic expressions into smaller pieces and solve those. That's going to be relevant since we're talking about area in this unit, which will deal with units squared. So we'll have lots of polynomials. We talked about circumference and arc length as a proportion of the total distance around a circle. And we talked about the area of a circle and sectors of a circle, which are a proportion of the total area. Those 3 concepts, if you master those this week, you will be in a great place next week when we really dive in to the more interesting features and properties of area. Thanks so much for tuning in. Have a great rest of your week.